When designing a commercial building's electrical system in Shanghai, it's crucial to understand the nominal system voltages for three-phase power. While research might suggest various values, the correct figures to use are 400 volts line-to-line and 230 volts line-to-neutral. These values are the standard for three-phase systems in China and differ slightly from those used in the United States, where the nominal voltages are 480 volts line-to-line and 277 volts line-to-neutral. To ensure compatibility with the local power grid in Shanghai, design the electrical system as a three-phase, Y-connected system with a line-to-line voltage of 400 volts and a line-to-neutral voltage of 230 volts. This configuration will allow equipment to operate correctly and safely within the Chinese electrical infrastructure. Failing to use these voltages could lead to equipment malfunction, damage, or even safety hazards. When selecting electrical equipment, such as transformers, switchgear, and distribution panels, ensure they are rated for these specific voltage levels. Confirm that the equipment is designed to operate efficiently and reliably at 400 volts and 230 volts. Check the manufacturer's specifications and certifications to guarantee compliance with Chinese electrical standards. Proper grounding is also essential for a safe and effective electrical system. The grounding system should be designed in accordance with Chinese electrical codes and regulations. This typically involves grounding the neutral point of the Y-connected transformer to provide a low impedance path for fault currents. An effective grounding system helps to minimize the risk of electric shock and equipment damage during fault conditions. Overcurrent protection devices, such as circuit breakers and fuses, must be carefully selected and coordinated to protect the electrical system from overloads and short circuits. The ratings of these devices should be based on the calculated load currents and the voltage levels of the system. A properly coordinated overcurrent protection system ensures that faults are quickly cleared, preventing damage to equipment and minimizing downtime. Wiring and cabling should be selected based on the ampacity requirements of the loads and the voltage levels of the system. Ensure that the conductors are adequately sized to carry the expected current without overheating. The insulation rating of the conductors should also be suitable for the voltage levels present in the system. Comply with Chinese electrical codes and standards when selecting wiring and cabling. Consider the ambient temperature and other environmental factors when determining the appropriate conductor size and insulation type. Regular maintenance and inspection of the electrical system are crucial for ensuring its continued safe and reliable operation. Schedule periodic inspections to identify and address any potential problems before they lead to failures. Maintenance activities should include checking connections, testing overcurrent protection devices, and inspecting wiring and cabling for signs of damage. Keep detailed records of all maintenance and inspection activities. Consider hiring a qualified electrical contractor with experience in designing and installing three-phase electrical systems in China. A qualified contractor can provide valuable expertise and guidance to ensure that the electrical system meets all applicable codes and regulations. They can also assist with the selection of equipment, the coordination of overcurrent protection devices, and the commissioning of the system. Furthermore, conduct a thorough load analysis to determine the expected electrical demand of the commercial building. This analysis should consider all connected loads, including lighting, HVAC equipment, appliances, and machinery. The load analysis will help to determine the required capacity of the electrical service and the sizing of the various components of the electrical system. Be sure to account for future growth when performing the load analysis. The electrical system should be designed with sufficient capacity to accommodate any anticipated increases in electrical demand. This will prevent the need for costly upgrades in the future. Additionally, consider the use of energy-efficient technologies to reduce the overall electrical consumption of the building. Energy-efficient lighting, HVAC equipment, and appliances can significantly lower operating costs and reduce the environmental impact of the building. Explore the availability of government incentives and rebates for energy-efficient technologies. These incentives can help to offset the upfront costs of implementing energy-efficient measures. Also, ensure that the electrical system is properly labeled and documented. Clear and accurate labeling of all components of the system will facilitate maintenance and troubleshooting. Maintain up-to-date documentation of the system, including wiring diagrams, equipment specifications, and maintenance records. This documentation will be invaluable for future reference and for any modifications or repairs to the system. Integrate a power quality monitoring system to track the voltage, current, and other electrical parameters of the system. This system can help to identify power quality issues, such as voltage sags, swells, or harmonic distortion. Addressing these issues promptly can prevent equipment damage and improve the overall reliability of the electrical system. Communicate effectively with the local utility company to coordinate the connection of the electrical service to the grid. Obtain all necessary permits and approvals before commencing any electrical work. Ensure that the electrical installation complies with all applicable local codes and regulations. By carefully considering these factors and working with qualified professionals, you can design a safe, reliable, and efficient three-phase electrical system for your commercial building in Shanghai. The 400 volts line-to-line and 230 volts line-to-neutral voltage levels are paramount to guaranteeing correct operation. This ensures that all electrical components and systems are designed and installed with the appropriate safety measures and protection mechanisms, preventing accidents and ensuring compliance with local safety regulations. Regular inspections and maintenance are crucial to identify and rectify any potential hazards, ensuring the longevity and safety of the electrical system. The use of appropriate safety gear and protocols by qualified personnel further enhances safety during maintenance and repairs. In addition to safety, efficiency is a critical aspect of electrical design. Employing energy-efficient technologies and practices can significantly reduce energy consumption and lower operating costs. High-efficiency lighting systems, variable speed drives for motors, and smart building management systems can all contribute to improved energy efficiency. Conducting regular energy audits can help identify areas where energy consumption can be further optimized. Reducing energy consumption not only lowers costs but also minimizes the environmental impact of the building. Furthermore, proper planning and coordination are essential for a successful electrical design project. This includes conducting thorough site assessments, developing detailed electrical plans, and coordinating with other building trades. Effective communication and collaboration among all stakeholders can help prevent delays and ensure that the project is completed on time and within budget. Engaging qualified electrical engineers and contractors with experience in similar projects can provide valuable expertise and guidance throughout the design and construction process. Their knowledge of local codes, regulations, and best practices can help ensure that the electrical system meets all requirements and performs optimally. Also, consider the future needs of the building when designing the electrical system. Anticipate potential expansions or changes in usage patterns and design the system with sufficient capacity to accommodate these future needs. This can prevent the need for costly upgrades or modifications later on. Utilizing modular and scalable electrical equipment can provide flexibility to adapt to changing requirements. The design should also account for the integration of renewable energy sources, such as solar panels or wind turbines. Integrating renewable energy can reduce reliance on the grid and lower energy costs. The electrical system should be designed to safely and efficiently connect to these renewable energy sources. Moreover, the design should include provisions for surge protection to protect sensitive electronic equipment from voltage spikes. Surge protection devices should be installed at the main electrical panel and at individual equipment locations. A comprehensive surge protection strategy can prevent damage to equipment and ensure the reliability of critical systems. Consider the aesthetics of the electrical installation. While functionality is the primary concern, the appearance of the electrical equipment and wiring can also impact the overall aesthetics of the building. Conceal wiring and equipment where possible and use aesthetically pleasing fixtures and fittings. Proper lighting design can enhance the appearance of the building and create a comfortable and productive environment for occupants. A well-designed lighting system can also contribute to energy efficiency. And remember to document all aspects of the electrical design and installation. Maintain detailed drawings, specifications, and manuals for future reference. This documentation will be invaluable for maintenance, troubleshooting, and future modifications. Store the documentation in a safe and accessible location. By following these guidelines, you can design an electrical system that meets the specific needs of your commercial building in Shanghai, ensuring its safety, efficiency, and reliability. Working with qualified professionals and adhering to local codes and regulations are essential for a successful project. Remember to factor in aspects of resilience, especially given that Shanghai is a major metropolitan area. Consider backup power systems. Evaluate the need for backup power generation to ensure continuity of operations during power outages. This is critical for essential services and businesses. Backup power can be provided by generators, uninterruptible power supplies, or other energy storage systems. Consider the cost, reliability, and environmental impact of different backup power options. Ensure that the backup power system is properly maintained and tested regularly. Evaluate the need for redundant systems. Consider the need for redundant electrical systems to provide backup in case of equipment failure. This is particularly important for critical systems such as life safety systems and data centers. Redundant systems can increase the reliability and availability of the electrical system. Implement smart grid technologies. Explore the use of smart grid technologies to improve the efficiency and reliability of the electrical system. Smart grid technologies can provide real-time monitoring of energy consumption, optimize energy distribution, and enable demand response programs. These technologies can help to reduce energy costs and improve the resilience of the electrical system. Enhance cybersecurity measures. Implement robust cybersecurity measures to protect the electrical system from cyber attacks. This is particularly important for systems that are connected to the Internet. Cybersecurity measures should include firewalls, intrusion detection systems, and regular security audits. Ensure that all software and firmware are up to date. Implement a disaster recovery plan. Develop a comprehensive disaster recovery plan to address potential disruptions to the electrical system. The plan should include procedures for restoring power, repairing damage, and communicating with stakeholders. Test the disaster recovery plan regularly to ensure its effectiveness. Promote energy conservation awareness. Educate building occupants about energy conservation practices. Encourage them to turn off lights when leaving rooms, unplug electronic devices when not in use, and use energy-efficient appliances. Raising awareness about energy conservation can help to reduce energy consumption and lower operating costs. Monitor the performance of the electrical system regularly. Track key performance indicators such as energy consumption, power quality, and system reliability. Analyze the data to identify areas for improvement. Use the data to make informed decisions about maintenance, upgrades, and energy conservation initiatives. By implementing these strategies, you can enhance the resilience of your electrical system and ensure its continued safe and reliable operation, especially when designing the system to use the Chinese voltages of 400 volts line to line and 230 volts line to neutral. This involves selecting appropriate equipment, implementing robust protection measures, and promoting energy conservation awareness. A well-designed and maintained electrical system is essential for the success of any commercial building.